Go.
Good evening. My name is Emaya Marie Moss. I recently attended the Academy of Future Physicians and Medical Scientists. While I was there, we were given a challenge to develop a theory that we thought could greatly benefit the world. There were many things that came to mind to research, from HIV to Alzheimer's, but the one thing I knew I had to and wanted to research was Hodgkin's lymphoma. My grandmother passed away from Hodgkin's lymphoma in 2012. When she passed away, there were many questions that I had left that were unanswered. So I knew that researching this would give me motivation to find a better treatment than the ones available. Hodgkin's lymphoma is a blood cancer that begins in a subset of white blood cells. With this cancer, you develop tumors in your lymph nodes, and the tumors then spread throughout the bloodstream, diffusing the cancer throughout the body. The common treatments available are chemotherapy, radiation therapy, biological therapy, and targeted therapy. Chemotherapy is a treatment with the use of chemicals that start from a high dosage and lower the dosage as you continue the treatment. Radiation is the use of high radiation to shrink tumors. Biological is the use of natural or laboratory-produced cells to build your immune system, and targeted is medication used to block the growth of cancerous cells. These treatments can be manipulated and combined to meet the needs of the patients. But the one thing that they all do is they hurt good cells, leaving the patients with a long recovery time, a weak body, and a broken spirit. First off, when cancer is present in the body doesn't send phagocytes out to assess the situation unless it is abnormal. So by the time the phagocytes are signaled, the cancer has formed tumors and began to diffuse throughout the bloodstream. Hence the reason why the diagram shows a cluster of cancerous cells and not one single cancer lymphocyte. At this time, patients begin to experience symptoms, so the patient's qualitative observations depicts their initiative to go to the doctor and receive help. Because at this point, they need to receive treatment because the cancer will start to grow more aggressively. Phase 2. Next, phagocytes then ingest the protein found on the outside of the cancerous cluster. The ingestion of the antigen is identified by the red outline. This also represents the reading or processing of the antigen. So once the phagocytes identifies it as an attack in the body, the T cells are signaled. Many T cells descend to the side of concern, but the main cells that have great significance are the chemokine T cell, the cytotic T cell, and the memory T cell. The memory T cell holds the antigen for future references. The chemokine T cells repairs the site of injury, and the cytotic T cells destroy the tumors and cancerous cells. Problems with this natural method. The body only responds once the cancer grows rapidly and aggressively, and the cytotic T cell will not be able to replicate as fast as the cancer. This is because the cytotic T cell was not stimulated at the right time. So the main problem is speed, and when it comes to battling cancer, time is essential. So during my research, my question was, how do you get the body to attack faster? I went through many ideas, but the one idea that seemed promising was exposing people more susceptible to Hodgkin's lymphoma to the protein corresponding with this specific cancer. So my theory, the antigen found in 94% of those with Hodgkin's lymphoma is CD30. This leads to my theory of inducing people most likely to get Hodgkin's lymphoma with the antigen. By doing this, you disrupt the homeostasis of the body with the CD30. So if the protein were ever present again, the body would fight it on sight versus processing the antigen all over again because it is already stored in the memory T cells. So by synthetically or naturally building CD30 and processing it into liquid form and giving it via shot in the bloodstream will help you build a first defense. The body's theoretical response to Hodgkin's lymphoma when induced. The red outline on the outside of the memory T cell signifies that it is storing the CD30 antigen. The memory T cell will immediately identify the CD30 antigen as an attack and stimulate the replication for the T cells to destroy the cancer. And since the body has been stimulated at this ideal amount of time, the cells will replicate just as fast as the cancer. Notice that this cancer is identified by one single lymphocyte and not a cluster. This is because the CD30 is not foreign in the body and does not need to be wait to be signaled by the phagocytes. How will the antigen help? It will create a first line of defense for your body. It will allow for lower dosages of medicine, and a lower dosage will help the body be more resilient and create faster recovery for patients. If the cancer is able to deflect the first line of defense, it can work with treatments in my previous slides by allowing you to lower the dosage because there will not be as much cancer present. And a lower dosage creates a more buoyant patient, and this will save money and faster recovery time, and more importantly, lives. Candidates for the antigen. People most likely to receive the antigen are those who have contracted the EBV virus, the Epstein-Barr virus, also known as mono, have a history of Hodgkin's lymphoma in their family, and have a history of abnormal amounts of infections. Studies show that if you have contracted the EBV virus, you have a 50% chance of getting Hodgkin's lymphoma. This is because when you contract EBV, it enlarges your lymph nodes and creates room for error as your lymph nodes fight off the virus. So the antigen CD30. It creates a first line of defense, allows the body to become more resilient, lowers the dosage of medicine, causing less damage to the body, and saves money and saves lives. Hearing the stories at the Future Leaders Conference have greatly inspired me and motivated me in my research to keep searching for a solution to my grandmother's cancer. This may not be a cure, but it is one step in the right direction. This research could lead to solutions concerning other cancers like breast cancer and lung cancer by using antigens found in each cancer to develop a cure or vaccination. I am very grateful for my experience and have all confidence in my research. Thank you.